Hi friends, I am Sunil working as Bsnl JE. Welcome to Bsnl JE 2016 exam preparation. Okay. In this video, I am going to discuss part 3 specialization. Part 3 specialization. In this specialization, I want to explain electrical part. Coming to the first topic, three-phase versus single-phase supply. Three-phase versus single-phase supply. Okay, I don't want waste your time. I will explain very briefly according to our JE syllabus. According to our Bsnl JE syllabus. First topic, three-phase vs single-phase supply. Okay, three-phase vs single-phase supply. What is a single phase? What is a three-phase? Single phase. For the single phase, there is only one phase. There is only one phase and neutral. The current flowing through this phase, and the return path is provided by this neutral. Okay. For single phase, the phase voltages and line voltages are same. There is voltages are same, that is nothing but phase voltages and line voltages are same, and also currents, phase currents and line currents are nothing but same. Okay, next coming to three phase system or three phase supply, there are three phases are there. They are nothing but R phase, Y phase, B phase. There are three phases and neutral. Okay, R, Y, B are nothing but phases. Okay, all of you confusing what is a phase voltage, what is a line voltage, what is phase current, what is line current. I will explain what is a phase voltage. Nothing, phase voltage is nothing but voltage between phase and neutral, or voltage between phase and neutral, voltage between phase and neutral. This is phase voltage. Voltage between phase and neutral. Voltage between phase and neutral is phase voltage. That is nothing but, for example, case of three phase, VRN. Voltage between phase and neutral. What is a line voltage? Line voltage is voltage between two phases. Voltage between two phases. That is voltage between R and Y, or voltage between V and Y and B, or voltage between B and R. Nothing but example, voltage between V, R and Y. R and Y are phases. Okay, so the voltage between two phases is line voltage. RY or nothing but VYB or nothing but VBR. These are line voltages. Okay. Next, what is a phase current? What is line current? What is a phase current? The current passing through any of the one phases. Any of one phase is phase current. That is nothing but IR, IY, IB. These are nothing but phase currents. IR, IY, IB. These are phase currents. Next, what is the line current? It is a vector sum of two phases. Vector sum of two phases is line current. Vector sum of two phases is line current. That is, for example, IRY. IRY equal to vector sum of IR plus IY. This is a line current. Okay. Once again, what is a phase voltage? Voltage between phase and neutral. What is line voltage? Voltage between two phases. What is phase current? Current passing through the any of the phase. What is line current? Current. This is vector sum of any two phase currents. Okay. Next one, winding displacement. Windings displacement. That means in case of three phases, how the windings are displaced. For example, if you take any machine, the armature windings are displaced by an angle. What is that angle? that is the electrical displacement equal to 360 degrees by number of phases. 360 degrees by number of phases. For example, three phase winding, electrical displacement equal to 360 by number of phases. Nothing, for three phase number of phases are 3, that equal to 120 degrees. For example, 6 phase, this electrical displacement equal to 360 by 6, number of phases are 6, that is 60 degrees apart. Okay, in this way the windings are displaced. Okay, but this formula not applicable to two phase system. Why? Because for two phase windings are displaced only 90 degrees. Displaced 90 degrees apart. For two phase windings are displaced 90 degrees apart. Okay. Next one, phase sequence. What is a phase sequence? This is nothing but sequence of phases. We know for three phase, these three phases are nothing but R, Y and B. For the sequence of phases is nothing but RYB or RBY. For in case of RYB phase sequence, VR means R phase voltage equal to Vm sin omega t. Take it as a reference. Then Vy is omega t minus 120 degrees. Vb means minus 240 degrees. That means take it, VR is a reference. See nothing but VR. Then Vy is 120 degrees apart. 120 degrees. After this 120 degrees. This is Vy, this is Vb. In case of RBY phase sequence, B at an angle minus 120, Y at an angle minus 240. Okay, minus 240. Next, what are the advantages of three phase over single phase supply? What are the advantages? First main advantage is it will gives greater output. It is nearly 1.5 times. Second one, motors. Three phase motors are more efficient. Because they give 1.5 times output of single phase. So most efficient means most economical or more economical. It will give constant power, and that means there are no power swings or no power variations. So they will give constant power. And this three-phase supply also, for this three-phase supply, parallel operation also is very simple. What is meant by parallel operation? Parallel operation means if we want higher rating, two systems are connected parallelly to get that higher rating. Okay, two small ratings machines are connected parallel to get the higher ratings. Okay, these are parallel operation. The parallel operation is very simple in case of three phase. What is a balanced and what is unbalanced circuits? A three phase system is said to be balanced. It must follow two points. First one is the voltage magnitudes are same. In all three phases. That is VR equal to Vy equal to Vb. Okay. And the second one is these three phases are displaced 120 degrees apart from one another. These three phases are must be displaced 120 degrees apart. Then if any system follows these 2 points, then it is said to be balanced circuit. Otherwise, then it is said to be unbalanced circuit. Okay, once again it must follow 2 points. First one is voltage magnitudes are same, and second one they are displaced 120 degrees from one another. Okay. Next topic, star delta connections and relation between line and phase voltages. Star delta connections. First one, star connection. First one, star connection. This is the star connection. This is R phase, Y phase, B phase. This is phase sequence is RYB, RYB, and this is the neutral point. Okay. For in case of star connection, line voltages are displaced 120 degrees. Line voltages are displaced 120 degrees. And here line voltage V line equal to root 3 phase voltage. For in case of star connection, line voltage VL equal to root 3 V phase, and line currents are same. For star connection, line currents are same, that is I line equal to I phase, and the total power P equal to 3 into V phase into I phase into cos pi. 3 into V phase into V phase I phase cos pi. Cos pi is a power factor. Pi is an angle between V phase and I phase. Phi is an angle between V phase and I phase, or nothing but P equal to root 3 VL IL cos pi. Root 3 VL IL cos pi. Line voltages are 120 degrees apart. Okay. For in case of delta connection, line voltages are equal to phase voltage. Line voltage equal to phase voltage, and line current equal to root 3 I phase. Here currents are different for delta connection. Total power is same. Either star connection or delta connection, the total power is same. Here for delta connection, line currents are 120 degrees apart. Okay. Once again, in case of star connection, line voltage equal to root 3 into phase voltage. Star connection, line currents are equal to phase currents. For in case of delta connection, line current equal to root 3 phase current, and line voltage equal to phase voltage. Okay, remember them, very very important. Okay. Next topic, power factor and their measurement. What is a power factor? Power factor is nothing but cos pi. I already said what is pi. The angle between pi is angle between voltage and current. What is power factor? We can define the power factor as cosine angle between phase voltage and phase current. Very very important, this phase, only phase voltage and phase current. Cosine angle between phase voltage and phase current, that is power factor equal to cos pi. Pi is angle between V phase and I phase. And one more definition is power factor equal to true power to the apparent power. What is a true power? Nothing but true power means nothing but active power. Active power is Vi cos pi by Vi, that is cos pi. That is nothing but power factor. Okay. Next, we have to know what is impedance. In case of DC circuit, there is only resistance only, but in case of AC, there is a impedance. That means resistance plus reactance. Okay, that is Z equal to root of R square plus X square. The units of impedance are nothing but ohms. Here X means reactance. Impedance triangle, that is R. Here this is the R vector, and the X vector is 90 degrees to the R, X vector. The resultant E is Z vector, that is nothing but impedance vector. From this impedance triangle, we can find the power factor cos pi. Cos pi means R by Z. Or nothing but pi equal to tan inverse of X by R. Okay. Here admittance. What is admittance? Admittance is nothing but it is denoted by Y, it is reciprocal of impedance. Reciprocal of impedance. That is units are mhos. Units are mhos or Siemens. Next, different power factors. Nothing but first one, unity power factor. Unity power factor, UPF. What is unity power factor? When the voltage and currents are in phase, that is pi equal to 0 degrees. For this, cos pi equal to cos 0, that is equal to 1. So power factor is unity. For resistive circuits, V and I are in phase. So for resistive circuits, the power factor is unity. For resistive circuit, the power factor is unity. For example, for incandescent bulb, the power factor is dash, unity, because the incandescent bulb is resistive circuit. And we know that power factor equal to true power by apparent power. But power factor equal to 1 means true power equal to apparent power. True power equal to apparent power. Next, lagging power factor. What is a lagging power factor? That means the current lags the voltage by pi angle, then it is said to be lagging power factor. Current lags voltage by pi angle. For inductive circuits, the current lags voltage by pi angle. So for inductive circuits, the power factor is lagging. The power factor is lagging. For this, true power is less than apparent power. Next, what is leading power factor? Leading power factor means the current leads the voltage. The current leads the voltage by angle pi degrees. For capacitive circuits, the current leads the voltage. So for capacitive circuits have leading power factor. Here also true power is less than apparent power. What is zero power factor? ZPF. When the phase difference between voltage and current is 90 degrees, voltage and current 90 degrees, then power factor equal to cos pi equal to cos angle is nothing but 90 degrees. Cos 90 equal to 0. That means 0 power factor. For pure capacitor and inductors, the power factor is 0. Next, power factor can be unity or less than unity, but never be greater than 1. Okay. Power factor can be unity or less than unity, but cannot be or never be greater than 1. Next, causes of low power factor. What are the causes of low power factor? What are the not causes? Consequences of low power factor. If the power factor is low, then useful power will be reduced. I will explain. If power factor equal to 1 and voltages and currents are likewise, then active power P equal to VI cos phi. For in case of single phase supply, 230 I means 1 amps and cos phi is 1. So the total active power is 230 volts. In case power factor is 0.5, then power P equal to 230 into 1 into cos pi means 0.5. That is 115 watts. That means active power reduces. For low power factor, the active power reduces. Okay. Due to this low power factor, losses are increases. So efficiency of the system decreases. As losses increases, efficiency will be decreases. The efficiency is decreases, that means the cost of generation and transmission increases. So to overcome this, what are the methods to improve the power factor? Methods of improvement of power factor. There are mainly two devices. First one, by using capacitor, or second one, synchronous condensers. By using capacitors or synchronous condenser, we can improve the power factor. How it is means, for example, this capacitor, in case of capacitors, the current leads the voltage. If the original system, this is voltage and the current lags the voltage, by angle pi. The capacitor leads the capacitor currents leads the voltage, that is nothing but IC. This is angle pi c. So the resultant is nothing but this is the resultant current. So the pi is reduces. So as pi is reduces means cos pi increases. That means power factor increases. Okay. Next topic, construction and principles of various types of measuring instruments. I already explained this in instruments and measurements part 1, part 2, part 3. Okay. In next video I will explain remaining topics. Okay. Once again I will repeat all the topics. First one, what is a phase voltage, what is a line voltage, or phase currents or line currents. Phase voltage is nothing but voltage between phase and neutral. Line voltage is nothing but voltage between two phases. Okay. Next one, in case of star connection, line voltage VL equal to root 3 V phase and I line equal to I phases. In case of delta connection, IL equal to root 3 I phase, VL equal to V phase. Next, what is a power factor? Power factor is cosine angle between V phase and I phase, or it is true power to apparent power. Next, nothing but what is a unity power factor? Voltage and currents, voltage and current are in phase, then it is unity power factor. For example, resistive circuits. In case of inductive circuits, power factor is lagging. In case of capacitors, power factor is leading. And zero power factor, then voltage, the angle between voltage and current is 90 degrees, then it is a zero power factor. Next, what are the consequences of low power factor and what are the improvement methods of power factor? Okay, thank you friends.